Have you ever wondered if it's possible to travel faster than light? It's a question that has sparked the imaginations of scientists, science fiction writers, and daydreamers alike. The allure of faster-than-light travel is irrefutable. It holds the promise of interstellar exploration, of crossing vast cosmic distances in the blink of an eye. It's a theme that has been explored time and time again in pop culture, from the warp drives of Star Trek to the hyperdrives of Star Wars. But it's more than just a dream. There is a scientific concept that might offer a glimmer of possibility. Yes, we're talking about warp drive. Today we will delve into the concept of warp drive, a theoretical proposition that might make faster-than-light travel possible. So, what exactly is warp drive? Let's break it down. Warp drive is a concept that's been floating around in the realm of theoretical physics, primarily associated with the idea of faster-than-light, or FTL travel. Now, how does it propose to achieve this seemingly impossible feat? It's all about creating a warp bubble around a spacecraft. But what does that mean? Well, imagine the fabric of space as a sort of cosmic rubber sheet. This warp bubble would essentially pinch a section of that sheet, altering the space around the spacecraft. This is not about moving through space in the traditional sense, but rather about moving the space itself. The origins of this concept are deeply rooted in Einstein's general theory of relativity, a revolutionary theory that drastically changed our understanding of gravity and the fabric of the universe. Einstein's equations allow for solutions that involve the contraction and expansion of space-time, forming the theoretical basis for warp drive. One such solution is what we call the Alcubierre drive, named after the physicist Miguel Alcubierre, who proposed it in 1994. The Alcubierre drive suggests that a spacecraft could achieve FTL travel within a warp bubble by manipulating space-time. It's about contracting the space in front of the spacecraft and expanding the space behind it, allowing the spacecraft to ride the wave of distorted space. This is akin to a surfer riding a wave. The surfer, or in our case, the spacecraft, isn't moving through the water or space, but is being carried along by the wave. The key is that while the surfer and the spacecraft are stationary relative to the wave itself is moving. While it might sound like something straight out of a science fiction novel, the theory of warp drive is grounded in Einstein's relativity. It's a testament to the boundless possibilities of human imagination and our relentless pursuit of understanding and exploring the cosmos. But as with any frontier of knowledge, there are challenges and uncertainties that we'll delve into next. However, warp drive isn't without its obstacles. The journey to achieving faster-than-light travel is filled with numerous challenges and uncertainties that scientists and researchers must overcome. One of the most significant hurdles lies in the need for exotic matter or energy. To create a warp bubble capable of distorting spacetime, we would need to manipulate matter or energy with properties that we have not yet observed in our universe. This exotic matter would need to exhibit negative energy density and negative pressure, a concept that is purely theoretical at this point. Think of it as trying to bake a cake with an ingredient that might not even exist. It's an incredibly daunting task, and the feasibility of such materials is still uncertain. But let's say we do find this exotic matter, or figure out a way to create it. That's just the first step. The next challenge is the energy requirements for creating and maintaining a warp bubble. And when we say energy requirements, we're talking about an immense amount of energy. Some estimates suggest we would need energy equivalent to the mass of the planet Jupiter. That's not just a lot of energy, it's an astronomical amount. Moreover, even if we could generate that kind of energy, we'd then have to figure out how to control it. Imagine trying to steer a car with the power of a rocket engine. It's an extreme comparison, but it gives you an idea of the scale of the challenge we're up against. And these are just the primary challenges. There are other, more intricate issues to address, such as stability of the warp bubble, avoiding undesirable time travel effects, and protecting the spacecraft and its passengers from potential hazards like high-energy particles and cosmic rays. The list of challenges is long and complex, and each one presents a significant hurdle to the actual implementation of warp drive. But as daunting as these challenges are, they also represent opportunities. They push the boundaries of what we know about our universe and drive us to explore, experiment, and innovate. As you can see, the road to warp drive is filled with scientific and technological hurdles. But remember, every great journey begins with a single step. And who knows? Perhaps one day we will take that giant leap for mankind and achieve faster than light travel. Despite these challenges, where does warp drive stand today? Well, it's important to note that as of my last update in January 2022, warp drive remains largely a speculative concept. It's a fascinating idea that has captured the imaginations of scientists, philosophers, and sci-fi enthusiasts alike, but no practical implementation has been achieved just yet. Now, this isn't to say that the concept of warp drive is purely the stuff of fiction. On the contrary, it has its roots in real, established physics, Einstein's general theory of relativity, to be precise. But the leap from theoretical physics to practical application is a significant one, and it's a leap we haven't yet managed to make. You see, the idea of warp drive is more prevalent in the pages of science fiction novels and the frames of Hollywood blockbusters than in the labs of our world's leading scientific research institutions. While it's true that theories such as the Alcubierre drive have given us a potential framework for understanding how warp drive could work, we're still a long way from turning these theories into reality. And yet the fact remains that warp drive in all its theoretical glory represents one of the most compelling possibilities for the future of space travel. It's a concept that has the potential to revolutionize our understanding of the universe and our place within it. So, despite the significant challenges and uncertainties that currently surround warp drive, the concept continues to inspire and intrigue us. It drives us to keep asking questions, to keep pushing the boundaries of our knowledge, and to keep striving for a future where the stars are not quite so out of reach. While warp drive remains a tantalizing possibility, it's important to stay grounded in the realities of our current scientific understanding and capabilities. So, is faster than light travel possible? That's the million-dollar question, isn't it? We've taken a deep dive into the concept of warp drive, exploring its roots in Einstein's general theory of relativity and the ingenious Alcubierre drive solution. We've looked at the idea of a warp bubble, a theoretical construct that contracts space in front of a spacecraft and expands it behind, allowing the craft to ride a wave of distorted space. Yet, we've also confronted the stark realities and immense challenges that warp drive poses. The need for exotic matter or energy with properties we've yet to observe, the monumental energy requirements for creating and maintaining a warp bubble, and the fact that, as of my last knowledge update in January 2024, warp drive remains largely in the realm of speculation and science fiction. While warp drive is a thrilling concept that fires up our imaginations and fuels our dreams of interstellar exploration, it's important to remember that it's just that, a concept. It's a theory that, while grounded in all established physics, faces tremendous hurdles in practical implementation. Perhaps one day we'll see the realization of warp drive. Until then, we can only dream and speculate about the possibilities of faster-than-light travel.